Hello everyone. This session deals with the CLRM and the various assumptions underlying the method of the ordinary least squares or OLS. So what is CLRM? CLRM stands for Classical Linear Regression Model. So what is regression? The term regression was proposed by Francis Galton, and regression analysis is concerned with the study of the dependence of one variable on one or more other variables with a view to estimating and predicting the mean value of the former in terms of the non or fixed values of the latter. To put it in simple words, regression is the study of the dependence of one variable on one or more explanatory variables. Explanatory variable is nothing but your independent variable. So, regression is the study of the dependence of the dependent variable on the explanatory variable, on one or more explanatory variables. So, this is one example, one simple example for a classical linear regression model. Here, y is your dependent variable, x is your independent variable, mu is known as the stochastic disturbance term or the error term. Beta 1 and beta 2 are the parameters or the regression coefficients. To be more specific, beta 1 is the intercept coefficient and beta 2 is the slope coefficient. This is the population regression function. Okay. Now, OLS or the ordinary least squares is an estimation technique used in regression analysis. The OLS method was proposed by Carl Friedrich Gauss based on the least squares criterion, and it is the most popular method used for regression analysis. Now, when we use the method of OLS or the ordinary least squares, we have certain assumptions in place, and there are 7 important assumptions. Let us go through each of them. So, the first assumption is we are assuming that the regression model is linear in nature. So, what do you mean by linearity? The regression model is linear in parameters, though it may or may not be linear in variables. Look at these two equations. We have two PRFs being written. Linear in the sense the power should be 1. So, in the first case, both the parameters, beta 1 and beta 2, they are raised to the power 1, as well as the variable is raised to the power 1. So, it is linear in parameter as well as in variable. Whereas in the second case, see, x is raised to the power 2. So, it is non-linear in the case of variable, but it is still linear in the case of parameters. So, both these equations, where it is linear in parameters as well as variable, or linear only in parameters, both can be considered as a linear regression model. Now, suppose I added a power 2 to the parameter beta 2. So, the equation becomes yi is equal to beta 1 plus beta 2 raised to the power 2 xi plus mu I. Is that a linear regression model? It is not a linear regression model. Why? Because it is not linear in parameters. So, you have to keep in mind that linearity means linear in parameters. It may or may not be linear in variable. Okay. The second assumption is x values independent of the error term. We know that x is the independent variable. So, x values and the error term are independent. So, what does this mean? The covariance between xi and mu I is equal to 0. Why is the covariance 0? Because they are independent of each other. Given the values of x, given the values of the independent variable, the covariance between the independent variable and the error term is 0. The third assumption is 0 mean value of the disturbance term. That is, the expected mean value of the error term is 0. Expected mean value of the error term is 0, given the value of the independent variable. The fourth assumption is homoscedasticity or constant variance of the error term. We know that homo means equal, scedasticity means spread or variance. So, homoscedasticity is equal variance or equal spread. So regardless of the value of the independent variable, all the error terms have the same variance. And usually variance of error term is equated to a constant sigma square. The opposite of homoscedasticity is heteroscedasticity. Hetero means unequal, scedasticity is again spread or variance. So heteroscedasticity is unequal variance. But if you are using the method of the ordinary least squares for regression analysis, we assume that the error term has homoscedastic variance or constant variance. The fifth assumption, no autocorrelation between the disturbances. So take two error terms. Take two stochastic disturbance term mu I and mu j, where I not equal to j, corresponding to two x values xi and xj. Then there is no autocorrelation between the error terms. So the covariance between two error terms mu I and mu j will be equal to 0 if x is non-stochastic. What do you mean by non-stochastic? We know that stochastic means random. So non-stochastic is not random. So fixed values or given values. So given values of xi, there is no autocorrelation between the error terms or the disturbance term. So the covariance between two error terms will be 0. The sixth assumption is the number of observations must be greater than the number of parameters to be estimated. So in order to estimate a regression model, you need to have a certain minimum number of observations which is higher in number than the number of parameters to be estimated. Then only you can do the estimation. And finally, the assumption deals with the nature of x values. The x values in the sample must not be the same for all the observations, and also there should not be any outliers. Now, what do you mean by outlier? An outlier means very large or very small values when compared to the rest of the observations. So there should not be any outliers and all x values should not be the same. So these are the important 7 assumptions of the CLRM when you use the ordinary least squares method of estimation. Now let us quickly summarize the assumptions. The first assumption was it should be a linear regression model, which states that it should be linear in the parameters. It may or may not be linear in the explanatory variable. The covariance between xi and mu I should be 0. That is, the independent variable and the error term are independent of each other. So the covariance between them will be 0. The expected mean value of the error term is 0 given the values of the independent variable. Homoscedasticity, equal variance of the error term. Covariance between two error terms, mu I and mu j, where I not equal to j and x is non-stochastic. Then the covariance between two error terms will be 0. Then the number of observations should be greater than the number of parameters in order to do the estimation. And finally, regarding the nature of x values, which tells us that all the values of x should not be the same and there should not be any outliers. So these 7 assumptions are the important assumptions that we make in regression analysis when we make use of the method of OLS as the estimation technique. That's all for now. Thank you.